Welcome to the Institute of Quarrying Australia's webinar. Today we'll cover the monitoring and measurement of respirable crystalline silica, one to meet the legislation requirements, but also to ensure the health and safety of your workers on site. Hi, I'm Paul Gerber. I'm a Principal Hygienist at Ohms Hygiene. I've been doing hygiene for about 20 odd years now. But also worked in the health and safety area across mining, quarrying, industrial sites at both a corporate as well as a on-site basis. So today I'm going to take you through a couple of different aspects of respirable crystalline silica and how to manage those particular issues. Today we'll cover three topics. So one of them is exposure monitoring. This will show you how to set up the respirable crystalline silica equipment to meet the requirements of the Australian standard. We'll also look at the difference between personal and static monitoring and where we use the two different types of monitoring. We'll also look at the monitoring program, how to design a robust system, but also how to validate the program via statistics and why we do that. Also, we'll look at what are the competencies that your exposure assessor should have or should aim to have to ensure that the monitoring program is valid. The last one we'll cover is monitoring results. We'll look at what are the good internal reporting requirements, reporting of exceedances internally, but also reporting of the results to regulators if required in your state. Currently, only Western Australia, Queensland and New South Wales have that requirement. And lastly, we'll cover on the information of the up-and-coming workshop and also look at what topics will be covered during that face-to-face workshop. So the first topic we'll cover is exposure monitoring. So we'll start off with personal air monitoring. You're required to do air monitoring to determine airborne concentrations of respirable crystalline silica at your workplace if you're not certain if you are exceeding the exposure standard, which is currently 0.1 milligrams per cubic metre or 0.05 milligrams per cubic metre if you've adopted the new Safe Work Australia standard, which came out on the 16th of December in 2019, or monitoring is necessary to find out if there's a risk to health. There's also a requirement to monitor if it's part of your legislation requirements. Legislation in some states won't specify that you'll need to do respirable crystalline silica, but it will basically say a person's got to conduct a business or undertaking at the workplace must ensure air monitoring is carried out to determine the airborne concentrations of substances or mixtures at the workplace to which an exposure standard applies. So a lot of them will not specify exactly what you need to monitor for, but this is where a good health risk assessment will look at various parts of your business and determine which health hazards are there and what is the appropriate controls you need to put in place, and monitoring is one of those control mechanisms to identify if your controls are actually working effectively. Air monitoring can help in assessing the risk to your workers by determining how much a worker has been exposed to, not just respirable crystalline silica, but also other potential contaminants that you may have on your site. Also looks at which processes or products are the source of exposure. Then you can look at how you can put controls in place around those to minimize exposure, and also if your controls measurements are effective. So one of the critical things when people are being monitored is completing the personal monitoring field sheets as accurate as possible to capture the work completed. And if there's any unusual activities, like if they're using a broom rather than a vacuum because a vacuum's broken down, this could generate more dust, and we need to know that. So if we're getting higher readings than normal, we can identify what processes or techniques have actually changed, and also highlight any controls that were not operating at the time or were not working as effectively. That also gives us a lot of information, especially if there's been an exceedance. We can look at, well, where is the potential breakdowns of the control mechanisms, and these are required to identify, especially when you're reporting back to a regulator. So air monitoring for respirable crystalline silica must be conducted in accordance with the Australian Standard 2985-2009 Workplace Atmospheres Method for Sampling and Gravimetric Determination of Respirable Dusts. By using this method for doing respirable crystalline silica, it ensures that everyone's using the same standard, they're using the same methodology to determine crystalline silica, but it also ensures that when you're comparing information across different sites, that you're comparing apples with apples. You're not using some other method that isn't approved, and it makes it easier to look at data across the business and say, well, what are the areas or the similar exposure groups that are most exposed? And it gives you some confidence that the methods are correct. There are two different methods to analyse respirable crystalline silica within the laboratory. There's Fourier transform infrared, FTIR, or there's X-ray diffraction, or XRD. Check with the laboratory prior to conducting sampling, as FTIR has a higher level of interference with other materials such as alpha quartz and cristobalite. So ensure that the people who are actually doing your monitoring find out if this material is on your site, and if it is, XRD is the preferred method because of the interference. So with your personal air monitoring setup, you've got a pump that's capable of running at 3 litres per minute. You've got tubing, then you've got your cyclone. In this instance, we've got a SKC cyclone. In the cyclone, you'll have another cassette with the appropriate filter inside there. It's important that the tubing's put on correctly. We've seen a lot of times where people put the tubing on backwards, so just make sure that the setup is as per the diagram on the right hand side. So we've got to calibrate the pump to 3 litres per minute against a calibrated secondary standard. You can't use the little rotameter or the flow indicator on the pump. You must use a secondary flow meter to accurately get 3 litres per minute. Ideally, you want 3 litres plus or minus 0.1 litre per minute throughout the entire sampling period. The flow pre and post calibration cannot be more than 5%. If it's actually greater than 5%, you actually got to make that sample invalid. So that's why you'll see occasionally results where they'll say invalid due to pump failure. It's because it's got to be no less than 5%. Ideally, sampling should be for the whole of shift. We want to see all the activities for that shift to make sure that we're getting an accurate representation of what the person's actually done over that work day. There's several different types of cyclones you can use for testing respirable dust and respirable crystalline silica. Just ensure you know which cyclone you're using, because each one does use a different flow rate. Look, check with the manufacturer or check with the occupational hygienist prior to do the monitoring, because if you use the wrong flow rate with the wrong cyclone, again, it'll be invalid sample and you've wasted that day monitoring. And like I said, with this example of 3 litres, it is only for the SKC cyclone. The next topic we'll cover is static air monitoring, what the advantages are, what the disadvantages are, and what the limitations are as well. So static, fixed or positional sampling can be used to measure area-specific dust levels and identify sources or causes of dust generation. This data can be used to prioritise or focus on dust control programs. It's used to identify where your basically dust hotspots are, where the biggest contributors are to personal exposure, if the people are actually working within that area on a regular basis. The equipment is similar to or identical to personal sampling. In this example, they're using a electric pump, not as easy to move around the site, but can be used. Historically, the personal monitoring pumps that we use are also used for static. The only difference is we run a longer tube, about 1.5 meters, so it's off the ground and roughly at head height. So static monitoring is a valuable tool for assessing effectiveness of process controls. For example, sampling before and after implementing a control to determine if the controls that you've implemented are actually effective. Dust measures collected at static points are not representative of actual work exposures and should not be compared to exposure standards. It, however, is a good indication if the controls are adequate to minimize the dust levels. What we mean they can't be compared to it because the person does not necessarily stand in that position for the full 8-hour shift or 12 hours if need be. So it's an indication of exposure, but you cannot compare those to the workplace exposure standard of 0.1 milligrams per cubic meter or 0.05 milligrams per cubic meter where they've been implemented. So with the air monitoring reports that you get from your consultant, or if you're doing it in-house, you must keep records of all air monitoring for at least 30 years. And these records must be readily accessible by workers if requested. Even if the quarry closes down, you must keep these records available for 30 years. So air monitoring reports should include a background and purpose of the air monitoring, including the current work exposure standard. That's critical so we can determine if that was a overexposure at that point in time. The task to be measured, including work patterns and hazards involved in the tasks. So this is important where we said earlier the field worksheets need to be filled out. This gives us that information on what hazards and what tasks are actually completing on the day. This normally would also be put into your reports. It just makes it more robust. Whether normal or unusual work or other conditions, example weather, was it a really windy day that day and it generated a lot more dust than normal, or equipment or controls not working adequately or not turned on. And this just gives us additional information, especially if there is an exceedance. We can start looking at an investigation on why it happened, because normally it will take a week to 2 weeks to get the results back. Conditions change day to day. By having that field worksheet correctly filled out, it gives us that information we can go back to and have a look at what the conditions were. Continuing on from the reporting, we want to know what control measures were in place and their performance. Were they on? Were they off? What sampling measurements were taken, including information on the calibration of the sampling equipment. We need that for verification that the equipment was actually pre and post calibrated and it was within the 5% variance. How and where the samples are analysed, including information on the calibration of the equipment. Again, you want to have that information of it's been sent to another laboratory, and you've got that certificate in the back of your reports as well. You want an interpretation of the results. So it's no use putting in a whole heap of information if you're not going to say, well, was this result over or under the exposure limit? And you want to know what the exposure sources were, adequacy of the current control measures as well. So the next topic we'll cover is the monitoring program. So to set up an air monitoring program, you've got to look at assessing the worker's exposure. You need to design an appropriate monitoring program. This should be based on the risk assessment that you've completed to look at who's exposed to respirable crystalline silica, but also this can be used for other contaminants as well as noise. It's a representative unbiased group should be included in the monitoring program. So if you look at the table, it's based on the NIOSH Occupational Exposure Sampling Strategy Manual. You need at least 6 samples to actually do statistics. If you've got less than 6, you can't do statistics and you can't validate that data. So if you've got less than 6 people, you've got to do 6 samples. If you've got 10 people, you've got to do 9. If you've got 50 plus, you do 22. This is based on, again, the NIOSH Occupational Exposure Sampling Strategy. This is also used by the Australian Institute of Occupational Hygienists and is predominantly used by most of the hygienists across the country to be able to put in a robust monitoring program. The NIOSH method is used to ensure there is a consistent approach to developing a baseline monitoring program. Once a baseline has been established and has been statistically assessed, these numbers can be reduced depending on the concentrations identified. Where monitoring programs are developed in accordance with legislation requirement, approval must be sought before changing any of the numbers down. Increasing the numbers isn't an issue, but if you decrease them, you need approval before you can actually do that. So why do we do statistic analysis on samples? Multiple samples, as per the previous slide, allow for a better understanding of variability of monitoring results. Statistic analysis of sampling results is important to assess how closely the results represent a true exposure profile and can be used to assess compliance with the exposure limit and assess the risk. It's also useful to identify the similar exposure groups or SEGs that are truly low risk and to reduce the sampling in these areas. If we've identified a very low risk, we can reduce the sampling regime to every 2 years or every 3 years and still be confident that we're not exposing our people. There is several useful statistic tools. One of them is called HiSat. It's an Excel tool developed by the American Industrial Hygiene Association, or AIHA. There's also a book called A Strategy for Assessing and Managing Occupational Exposures. This accommodates the tool and provides critical details on how to use and interpret the various information coming out of that. So if you are going to do your internal statistics yourself, it's called IHSTAT. Do a Google search. It will provide the information that you need to interpret your monitoring program. So with any of the monitoring and your monitoring program set up, next section we'll go through is monitoring the results, what you should be doing with the results and who you should be sending them to. So we'll look at air monitoring and the different methods that you can distribute the results to personnel. So if we look at internally, all air monitoring results, no matter what they are, not just respirable crystalline silica, not just exceedances, should be reported back to the individual who are monitored. It's normally in a letter format, so each individual gets a summary of what they were exposed to, interpretation of what those results are. A common format is to put it as a percentage of the exposure limit. So people can see that they're either 10% of the exposure limit, 50% of the exposure limit, or greater than the exposure limit. It just makes it a easier way of interpreting the information rather than having the actual result and then trying to work out what your adjusted exposure limit may be. So we normally will do it as a percentage of the exposure limit to make it easier for the individual to understand the results. A summary of these results for the air monitoring should also be available to other personnel who weren't monitored. So you might monitor 2 or 3 of your workforce, but there's 5 or 6 other people in that area that don't get monitored on that run. A good idea is to have a summary report in their area to see what exposure has occurred, what sort of levels during the latest campaign were, so people can understand what the levels in their area are. So a simple, quick way would be just put the similar exposure group, how many tests you've done, the minimum and maximum numbers, and also the number that were above the workplace exposure limit. That gives people an idea of what they've been exposed to. So reporting exceedances internally to your company. Exceedances to the workplace exposure standard shall be investigated to determine the cause. The cause of the exceedance shall be communicated to employees to minimise reoccurrence. The investigation is critical to determine what controls failed or what controls need to be implemented. Where this is a new exceedance in a particular area, was a worker doing something different to the other workers for the same task? Was there a piece of equipment that failed? Did they use a broom to get rid of the excess amount of material on the ground rather than using a vacuum or some other mechanism? Did they use high pressure air rather than another way of getting rid of the dust? Did they wash down the equipment or didn't they wash down the equipment? They're the sort of things we need to know for the exceedance, so we understand why exceeded. This is where the personal field sheets again are very important, where they can highlight that information to say, well, this is what I did, this is how I was doing the work, this is when I was doing the work, this is equipment that I was working on. So if there is an exceedance, we've got that information readily available, and it makes the investigation a lot more streamlined and less cumbersome to complete. Like I said earlier, reporting exceedances to the relevant state regulator is only applicable to Western Australia, New South Wales and Queensland. In Western Australia, it's as per clause 9.6 in the Mine Safety Inspection Regulation 1995. New South Wales, as per clause 128, Workplace Health, Mines and Petroleum Regulation 2014, and in Queensland, as per QGL 02, Guidelines for Management of Respirable Crystalline Silica, in Queensland, Mineral Mines and Quarries. In Western Australia, the ventilation officer must report to the manager or the manager's representative any atmospheric contaminant levels in a workplace, at the mine or quarry that exceeds the exposure standard. This is captured in clause 9.6 of the Mine Safety Inspection Regulation 1995. The sites are also required to electronically submit their atmospheric contaminant results, not just the exceedance but all results, within 6 weeks after the end of the sampling quarter to the Department of Mines, Industry, Regulation and Safety. For more information on the sampling requirements as well as the submission of results can be found in the DEMA's website by searching for reporting results of atmospheric sampling. Within Queensland, as per QGL 02 guideline, the SSE shall notify the mine inspectorate within 28 days of becoming aware of the results of the respirable crystalline sampling exceedance. The Institute of Quarrying Australia has invested in the development of a face-to-face workshop on respirable crystalline silica, which will be scheduled for delivery once COVID-19 restrictions are lifted. The workshop will cover information from this presentation in further detail, as well as the health effects of respirable crystalline silica, health risk assessment, control mechanisms, measurement and monitoring of exposure, communication and training requirements, as well as development of a principal hazard management plan, in particular for respirable crystalline silica. Thanks for listening. Any further details, please contact education at quarrying.com.au to register your interest in the up and coming workshops once they're available. Thank you. A range of fact sheets have also been developed on respirable crystalline silica, which are freely available from the Institute of Quarrying Australia's website at www.quarrying.com.au. So please have a look at those. It contains a lot of useful information on respirable crystalline silica.